Please listen this. In the first step, what we are going to do, those who missed the previous classes, please listen. Here, the first step of tension coefficient, we have to first consider the origin point. Now, what is the origin you can take? You can take either A, E, D, B, C, anything you can take. In general, considering the free end is a good option. Now, the origin point, I am considering it as C. Now, when I consider this as origin and the positive x-axis, I will consider the upward direction is my positive x-axis, and this positive x-axis towards right side, upward will be y-axis. This is 3 meters. This AC is also 3 meters. That is, it is making an angle of 45 degrees. 45 degrees. Then, obviously, you can tell me if this is 45 degrees, this distance is also 1.5 meters. This distance also 1.5 meters. Now, what is the origin? Origin is C, which is 0, 0. And what are the coordinates for B? Y-axis, there is no change here. So that's why this will be represented as minus 1.5, 0. The coordinates for B are minus 1.5, 0. Whereas coming to coordinate for A, what are the coordinates for A? Minus 3, 0. The coordinates for here A are minus 3, 0. If you go to D, what are the coordinates for D? The coordinates for D are nothing but along x-axis, that is negative minus 1.5, comma. This is 1.5 in the downward direction. Your positive x-axis is in the upward direction. So this is also minus 1. So the origin for this, the coordinates for D are minus 1.5, minus 1. Where if you go to point E, what are the coordinates for point E? Along x-axis, this is minus 3. Along y-axis, minus 3. Coordinates at E are minus 3, minus 3. In the first step, you are assuming. So write down the equilibrium equations along x-axis, along y-axis at each joint. Now considering the free end. Now we will consider the free end at C. So consider joint C and write the equilibrium equations. Consider joint C and write the equilibrium equations. So to write the equilibrium equations here along x-axis, along x-axis. So first mention this as joint C. At joint C, there is a vertical load of 10 kilonewtons is acting in the downward direction. Here tension force BC is there. Here tension force CD is, represent them as DC instead of CD. Why? Because your second term should be the joint where you are writing the equilibrium equations. Remember this, your first term will be the member other point, and the second C is nothing but where you are writing your joint. Where you are writing your joint. Now, what is the equilibrium equation that we need to write here? Along x-axis, xb minus xc, that is nothing but you are writing for first TBC. So xb minus xc into tension coefficient TBC plus xd minus xc into TDC. So this is nothing but the along x-axis, the difference between the coordinates along x-axis into tension coefficient of PC member plus coordinates for DC, difference between the coordinates for D and C into tension coefficient of DC member plus you are writing your equilibrium equations at x, that's why capital XC. So this XC is nothing but external force acting along x-axis. Is there any external force along x-axis? No,
10 kilonewtons.
along 0. So that's why this along x-axis there is no force, along y-axis only the force is acting. Now this xb, what is the value of xb? They are the coordinates. Minus 1.5 comma xc is 0 into tbc is your unknown. xd is this one, xd comma yd minus 1.5 minus 0 into tdc plus 0 equal to 0. And this will become minus 1.5 into tdc minus 1.5 into tdc. You can consider this as equation number 1. Now write down the equilibrium equations along y-axis. If I write along y-axis, that is yb minus yc into dbc plus yd minus yc into tdc plus yc is equal to 0. yc is equal to 0. Now substitute the coordinates along y-axis. Substitute the coordinates along y-axis. So yb is nothing but here, just go to the diagram that we have written it as yb is 0. So 0 minus 0 into tdc plus yd is nothing but minus 1.5. So this yd is minus 1.5 minus 0 into tdc. What is your yc? Just see. Your assumed axis for y direction is upward, but the load is acting 10 kilometers in the downward direction. So capital YD is minus 10 kilometers. Is very important. So what is the direction of the force? The direction, it is in the downward direction, but your assumed positive y-axis is in the upward direction. Assumed positive y-axis in the upward direction. Hence, this is to be considered as negative. Hence, write it as minus 10 equal to 0. Now, 0 minus 0 into TBC is 0 only here, and this is minus 1.5 TBC minus 10 equal to 0. That implies TDC is minus 10 by minus 6.67. Don't write any unit. This is a tension coefficient. So TDC is minus 6.67. Substitute this value in the above equation number 1 to get the value of TBC. So you get the values of TBC, you substitute the values. So minus 6.67 will be substituted minus 1.5 TBC minus 1.5 into minus 6.67 equal to 0. This implies TBC is plus 6.67. Just do the simplification and you will get the answer. So TBC will be 6.67. Just go to our diagram once. Go to the diagram once. What is the length of the member CD? Length of the member CD. So to get the length of the member of CD, write down LBC is 1.5 meters. That already it is a horizontal member. That's why you can easily find out. LBC is equal to 1.5 meters. LDC is nothing but you have to make it as a square root of 1.5 square plus 1.5 square. Yes or no? As it is a right angle triangle, so you have to make it as square root of 1.5 square plus 1.5 square. Otherwise, how we can do is xd minus xc whole square plus yd minus yc whole square. So xd, what is the value of xd? Minus 1.5 minus 0 whole square plus minus 1.5 minus 0 whole square. So you will get the value of TC member. Length of TC member will be obtained. What is the length of DC? Give the answer in the chat box. 2.12 meters, right? So the length of DC member is 2.12 meters. Write down this. After calculating the tension coefficients, you write down the length of the members DC as well as DC. So after getting the length of the members, you have to get the forces. So force in BC is nothing but tension coefficient multiplied with the length of the member. So TBC value is 6.67 multiplied with 1.5. We'll get it as 10 kilonewtons, which is tension. Similarly, TDC, which is small TDC into LDC, that is minus 6.67, 2.12, minus 14.14 kilonewtons. And this value is negative, hence it is an indication of compression force. Now at joint D, at the joint C, we completed the equilibrium equations along x-axis. This tension coefficient method is based on coordinate system. Instead of resolving the forces along x-axis or along y-axis with respect to the coordinates, we calculate the tension coefficients. These tension coefficients are multiplied with the length of the member to get the force. If that is positive, and that is an indication of tension force. If this is negative, then that is an indication of compressive force. Now, we here understand, as we are writing for a plane truss, the available equilibrium equations are two. Now, at joint C, why we considered at joint C? You may get a doubt. The thing is, the available equilibrium equations for a plane truss are two only along x-axis and along y-axis. Hence, when there are two equations available, you can solve only two unknowns. That's why wherever you are choosing a joint, the number of unknown forces should be less than or equal to 2. Now these two forces are calculated. Now we'll move to joint B. At joint B, how many unknown forces are there? EA or AB, DB. Now go to joint B and write the equilibrium equations. Consider joint B and write the equilibrium equations. first of all, along x-axis. To write these equilibrium equations, first of all, let us see at joint B, how many members are there, how many external loads are there. At joint B, there are three members that are meeting. That is, here a force is going, which is TAB. Another force is there, this is TCB. So remember here, what I am doing is, my second term will be the joint where I am writing the equilibrium. Just remember that point. Now, another vertical force is there, 25 kilonewtons here, downward direction. Then a member force is there, E, D, B. So these three members, they are meeting. Now, along x-axis, what is the equilibrium equation? XA minus XB into, it is along x-axis we are writing. So there are the joints, that is the member AB is there. So XA minus XB into tension coefficient TAB plus second member, this is the one, XC minus XB into TCB plus XD minus XB into TDB plus XB is equal to 0. Is the external force along x-axis. So here in this one, the force is in the y direction. There is no the external force along x-axis. So this term will become 0. Now substitute the values. XA, just go back to the coordinates that are available in the diagram. XA is minus 3, XB is minus 1.5. Minus 1.5. So this is minus 3 minus of minus 1.5 into DAB plus XC, origin, that is 0, minus of minus 1.5 into TCB plus XD. Just go to the diagram and see the coordinates. XD is minus 1.5. So minus 1.5 minus of minus 1.5 into tension coefficient TDB equal to 0. So just see this one, minus 3 plus 1.5 minus 1.5 into TAB, minus into minus plus 1.5 into TCB, minus 1.5 minus into minus plus 1.5, that is 0. That is 0 into TDB is 0 only, equal to 0. This is our equation number 3. So along x-axis, if you write, then the equations available are these are the ones. Now go to along y-axis. YA minus YB EAB plus YC minus YB into TCB plus YD minus YB TDB plus the what is along y direction, the external force that is acting at joint B. So YA, just go to the diagram and observe what are the coordinates along y direction. For A, 0, for B also 0, for D it is minus 1.5. Substitute those values and get the equation. So YA is 0 minus 0 EAB plus 0 minus 0 into TCB plus YD is minus 1.5 minus 0, YB is 0 only into TDB. And now observe your force along y direction at B. 25 kilonewtons is there. Your assumed axis is in the upward direction, but the force is acting in the downward direction. Hence, YB is minus 25 to 0. The negative is with respect to the assumed direction, it is in the opposite side. Now substitute the values. This is 0 into TAB 0, 0 into TCB 0. Here, this value is, here one thing we can do, we skip here at 3. Just understand here the value of TCB. TCB or TBC both are the same here. The value of TBC, that is tension coefficient of BC or tension coefficient of CB, both are the same. So you can substitute here 1.5 into TAB plus 1.5 into 6.67 equal to 0. That implies TAB is 6.67. Tension coefficient of AB is 6.67. Okay, now whereas coming to here, in this one, TAB, TCB, that is the coefficients are 0 here, minus 1.5 into TDB equal to, so TDB is equal to 25 by 1.5. Don't give any units. This is a tension coefficient. It is to be multiplied with the length of the member to get the force. Now let us see what is the length of the member AB as well as length of the member DB. DB is 1.5, AB is also 1.5. So multiply these tension coefficients with the length of the member 1.5 meters, you will get the force. So forces TAB is equal to tension coefficient multiplied with the length of the member, which is 6.67 into 1.5, that is plus 10 kilonewtons, which is tension. Tension TDB is TDB into LDB minus 16.67 to 1.5. So that is 25 minus 25 kilonewtons, which is compression. Minus 25, right. So TDB, TAB values are calculated is plus 10 kilonewtons as well as minus 25 kilonewtons, which is compression. Let's move to joint D. Consider joint D. And write equilibrium equations. Along x-axis. Now, first of all, let us draw the free body diagram. We'll understand how many members are meeting at joint D. Let us go to joint D and observe the diagram. At joint D, if you observe, here, one member is CD, ED, AD, as well as ED. Total 4 members are there. We did not bother about the angles. Why? Because this problem is based on the coordinate system, so don't bother about the angles. There are 4 members that are meeting here. So the members 4 are there. This is tension force C, a vertical force, but this is TBD. Here this is TED, and here TED. Now we will write down the equilibrium equation along x-axis. So along x-axis, when I am writing, that is first I will start from here. XE minus XD. That's why I am saying write the second term as your joint where you are writing your equilibrium equation. So simply you can remember E minus D, xe minus xd into DED plus xa minus xd. Always your second term will be the joint coordinate EAD plus xb minus xd into EBD plus xc minus xd into DCD plus capital XD equal to 0. Capital XD equal to 0. There is no external force acting at D either on x-axis or y-axis. So this term will become 0. Now coming to XE. So XE, if you go to the coordinates at E, we have already written them. That is minus 3 comma minus 3. That is XE is minus 3. YE is also minus 3. Now we substitute. Similarly, XD is minus 1.5. XA is minus 3. XB is minus 1.5. XC is 0. Substitute all the values. Substitute all the values. So this is minus 3 minus of minus 1.5 plus XA minus 3 minus of minus 1.5 into DAD plus XB. XB is minus 1.5 minus of minus 1.5 DBD plus 0 minus of minus 1.5 DCD equal to 0. So here this is minus 1.5 plus 1.5, that is 0 only. Minus 3 plus 1.5, that is minus 1.5 minus 1.5 into TAD. So this whole term is 0 into TBD, that is 0. Minus into minus plus 1.5 into TCD value. Is tension coefficient of CD. Do we calculate in the previous step? Just go to the previous steps. We already got the value of TDC minus 6.67. TDC or TDCD both are the same. So that is minus 6.67. Substitute the value minus 6.67. So here the entire equation minus 1.5 can be cancelled. So for simplification, take it as minus 6.67. Just am an equation. So this will be the equation number 5. Now, if you go for the along y-axis, write down the equation along y-axis, ye minus phi d plus ya minus phi d ad plus yb minus yd dbd plus yc minus yd into tce plus capital yd equal to 0. So here there is no external force acting, hence this will become 0. There is no external force acting at D. Something. So this is minus 3 plus 1.5 minus 1.5 into D plus 1.5 into DAD minus into minus plus into minus minus 1. Here this is minus 6.67 into minus plus 1.5, that is minus 10 Here you will get it as minus 1.5 TED plus 1.5 into TED equal to 35. So if you solve them properly, then this is becoming as equation number 6. Solving 5 and 6, EED is equal to TED is